Alright, let's crack open a tough GCSE chemistry exam question, but we're going to do it using a bit of a secret weapon, the official AQA mark scheme. We're going to peel back the layers on this high-stakes problem and show you exactly how to snag every single mark.
You know the feeling, right? You flip the page, see a question worth 6 or more marks, and it just looks like this impossible wall of text and numbers. It's so easy to feel overwhelmed before you've even picked up your pen. But what if I told you that that giant, scary question is actually just a bunch of small, easy ones all hiding together? Well, today, we're going to prove it. We're going to break down question 10, step by step, using the examiner's own playbook. Think of this as our little coaching session to get you totally exam ready.
Right, let's get into it. First up, before we hit the big calculation, there's usually a shorter question that's just checking you understand the concepts. And in this case, it's all about nanoparticles.
So this part is worth 2 marks, and it's asking for 2 specific reasons. The trick here is to be really precise and give them the exact properties the examiners are looking for.
And boom, here are the official answers, straight from the horse's mouth, the mark scheme. You only need to give any 2 of these to get full marks. The classic answer is always that high surface area to volume ratio, but remember, the other 2 are just as good for bagging those points.
So what on earth does that actually mean? Well, think of it like this. Imagine you've got a big sugar cube. Now, what if you smashed it into thousands of tiny grains? You've still got the same amount of sugar, the same volume, but you've massively increased the total surface that's exposed. That's what makes nanoparticles so reactive and so useful.
Okay, here we go. The main event. This is the 6-mark beast that can really make a difference to your grade. But don't you worry, we're going to chop it down into a simple step-by-step process.
This is our game plan, see? A 6-mark question isn't one giant, terrifying leap. It's just 6 small, manageable steps. We're just going to walk through them one at a time, and each step will unlock the next one. Let's do this.
Step 1. Mark 1. This is the foundation for pretty much any chemistry calculation, working out the relative formula mass, or MR. You'll have your periodic table with you, so this should be a nice, gentle start.
Okay, so to figure this out, we look up the numbers on the periodic table. Titanium is 48, and oxygen is 16. The formula is TiO2, so that's 1 titanium and 2 oxygens. We just add them up, 48 plus 2 times 16, which is 48 plus 32.
Which gives us 80. And just for writing that number down, with the right working, you've already earned your first mark. Simple as that. We're off and running.
Okay, let's move on to step 2. Now, for the second mark, we've got to deal with units. Chemistry calculations almost always use grams, but the question gives us the mass in kilograms. This is a classic little trick designed to catch you out, so always be on the lookout.
The question gives us 100 kilograms. To get that into grams, we just multiply by 1,000, which gives us 100,000 grams. Getting this conversion right is absolutely essential, and it locks in that second mark for us.
So, now we can use the answers we just worked out in the first 2 steps. We've got our mass in grams, we've got our MR, it's time to calculate the number of moles. The formula is always your best friend here. Moles equals mass divided by MR.
So we take our 100,000 grams and divide it by our MR of 80. Pop that into the calculator and you get 1250 moles. Fantastic! That's mark number 3 in the bag. We're halfway there.
Okay, now we need to look at the balanced symbol equation that's in the question. This equation is like a recipe. It tells us the ratio of ingredients. It shows that for every 1 mole of our titanium dioxide, we make 2 moles of chlorine gas. That 1:2 ratio is the absolute key to this next part. So since the recipe is 1:2, we just take our 125 moles of titanium dioxide and we double it. That gives us 2,500 moles of chlorine. And get this, according to the mark scheme, doing this correctly actually bags you 2 marks. So that's marks 4 and 5 banked in one go. What a great deal.
We are on the home stretch now, the final step. We just need to turn the moles of chlorine gas we just found into a volume. The question tells us that 1 mole of any gas takes up 24 decimeters cubed. So the formula is just volume equals moles times 24.
We take our 2,500 moles of chlorine, we multiply it by 24, and the answer is 60,000 decimeters cubed. And that's it. That's the final answer, and that secures you the 6th and final mark. We did it! 6 steps, 6 marks. Nailed it!
Phew!
So, what did we learn from cracking open that mark scheme? It's not just about getting the final answer right, it's about showing the examiner you know the process. Let's quickly recap the key strategies.
So what's the game plan? First, always show your full working out. We saw how every single step got us a mark. Second, double-check your units. That kilogram to gram conversion is a classic trap. Third, use that molar ratio from the equation. It's the bridge that gets you to the answer. But most importantly, break down the big problems into small steps. And finally, practice, practice, practice.
I want you to remember this phrase. The next time you see a high-mark question, don't panic. Just see it for what it is, a little chain of simple, one-mark questions. You absolutely have the tools to solve it, one link at a time.
Hopefully you're feeling a whole lot more confident now. The mark scheme isn't some big secret. It's literally a guide to what the examiners want to see. So, what tough topic or monster question should we decode together next? Let us know.